In this video, I am going to derive the equation of the Mohr circle. Suppose this is a block of a rock, and in this block of a rock we are applying some amount of stress, and the principal stress axes that are mutually perpendicular to each other can be oriented like this. This is the maximum principal stress axis, sigma 1. This is intermediate principal stress axis, that is sigma 2, and this is minimum principal stress axis, that is sigma 3. And because of this stress in this block of rock, there is a fracture plane or the fault plane that you can see here as a red plane passing through this block, and this is the trace AC of this plane. Suppose the area of this fracture plane or the fault plane is 1 unit. Taking this PQRS view in this frame, okay, and this AC is the trace of this fault plane or the fracture plane, okay. And now I have a triangle ABC in which if I made a line BD which is perpendicular to AC, I have a right angle, that is 90-degree angle here, okay. So this is also a 90-degree angle. So I have now two small triangle ABD and BCD. Now the theta is the angle between the minimum principal stress axis sigma 3 and the trace of the fault plane or the fracture plane. Now I am going to derive the equation of the Mohr circle. At first I am going to take the triangle BCD. So in triangle BCD, the sine theta is equals to BD divided by BC, that means perpendicular upon hypotenuse. So BD is parallel to sigma n, so I can write sigma n instead of BD, and as you can see sigma 3 is parallel to BC, so I can write the BC as sigma 3. I can rewrite this equation as sigma n is equals to sigma 3 sine theta. Suppose this is equation number 1 that we are going to use very soon. Similarly, in the same triangle BDC, the cos theta is equals to sigma s divided by sigma 3, okay. So this will be this CD is equal to sigma s and this BC equal to sigma 3, or we can rewrite this equation as sigma s is equals to sigma 3 cos theta. Similarly, in triangle ABD, we have sine theta is equals to sigma s divided by sigma 1, or we can rewrite this as sigma s equals to sigma 1 sine theta. Similarly, cos theta in triangle ABD is equals to sigma n upon sigma 1, or we can rewrite this thing as sigma n is equals to sigma 1 cos theta. So now we have these four equations that I am going to use very soon to get the equation of Mohr circle, okay. So this is 90 degree, this is 90 degree minus theta, so this becomes the theta, okay. So we have these equation sigma n, these 1 2 3 4 4 equation. Now we can see here that if in this triangle, if I am taking AC as 1 unit. AC is actually the trace of this fault plane or the fracture plane, and if I am taking the area of this fault plane or the fracture plane whose trace is AC is as 1 unit, then AB will be equal to sine theta and BC equals to cos theta. So the area of the plane having trace AB has sine theta, area sine theta, and the area of the plane having the trace BC have the area cos theta. Okay, so we also have to use this equation. Okay, these equations 5, 6 and 7, this equation in the derivation. Okay, now we all know that stress is equals to force per unit area, so we can rewrite the force as stress multiplied into area. Okay, now if you take a look over this triangle here, okay, and how these different stress are oriented along a point in this plane AC. Okay, so we can see that if F3 is the force that is being applied by sigma 3 and F1 is the force that is applied by the sigma 1, the orientation of force that is applied by sigma n will be equal to Fn, and from here we can clearly see by the orientation of these vectors of force, we can see that Fn is equals to F1 plus F3. Okay, and let it be the equation 8. Similarly, now I am going to tell you the relationship between F1, the force by the stress sigma 1, force 3, F3, that is the force by sigma 3, and sigma s, Fs, that is the force that is being applied by the stress sigma s. Okay, so orientation of F1 will be like this, the orientation of F3 will be like this, but the orientation of Fs is like this. That means F3 is in the opposite direction. So I can get the equation from this orientation of these force vector as Fs, that is the force being applied by the stress sigma s, is equals to F1 minus F3, and this is equation number 9. Now using all this equation from 1 to 9, we have to derivate the equation of the Mohr circle. From the equation number 8, we know that Fn is equal to F1 plus F3, and as we also know that F is equals to stress multiplied by area, so I can rewrite this equation in the form of stress if I multiplied to these forces by their respective areas. Okay, so sigma n multiplied by 1, as sigma n, as you can see here, that sigma n is applying on this trace AC, that is the fracture plane or the fault plane. Okay, so sigma 1, and this F1 is equals to sigma 1 cos theta. From the equation number 4, as from the equation number 4 we can see that this is sigma 1 that is being applied on this along this BC. Okay, so area of BC was cos theta, so I am again writing the cos theta. This is the stress component along F1. Similarly, I can write this thing for this F3 using the equation sigma 3 sine theta that I got from equation number 1. Sigma 3 sine theta multiplied by sine theta, because this sigma 3 is applying on AB, having the area sine theta. Okay, and using the equation, these two equations of trigonometry, okay, we can rewrite this formula as sigma n is equals to sigma 1 plus sigma 3 upon 2 plus sigma 1 minus sigma 3 upon 2 cos 2 theta. Similarly, using the equation 9, that was Fs equals to F1 minus F3, we can rewrite this thing as sigma s multiplied by 1, because Fs was this sigma s was oriented along this AC trace of the fault plane. Okay, so sigma s equals to sigma 1 sine theta multiplied by cos theta minus sigma 3 cos theta minus sine theta. And using the trigonometric equation, this we can rewrite this thing as sigma s is equals to sigma 1 minus sigma 3 upon 2 sine 2 theta. And these two equations are the equation of circle, and these are the equation of Mohr circle, where sigma 1 minus sigma 3 upon 2 is the radius of the Mohr circle, and sigma 1 plus sigma 3 upon 2 is the coordinates, the position of the center of the Mohr circle with respect to 0, 0 coordinates. Thank you.